Hey gang, super short notes, last day of Unit 5, proofs, and then some more theorems. Some common reasons that we'll be using for our similarity proofs would be like our vertical angles, these guys, our three similarity proofs from last time, angle pairs with parallel lines. So for instance, if you've got two parallel lines, you've got alternate interior angles, like those two being congruent, our algebra properties, and then the new one, which is CSSTP. Corresponding sides of similar triangles are proportional. It's really similar to CPCTC from our last unit, in that you must first prove that the two triangles are similar, and then you can go back and use the fact that the corresponding sides must then be proportional. Let's try one, and then we'll have some more to do in class. Given information, which I would want to put in my picture, is that AC and MP are parallel. That's what these little triangles mean here. I like to sort of extend those parallel sides because it helps me kind of get a better idea of what's going on. So I've got my two parallel lines. And then the next thing that they're giving me in the proof, after the given, is that angle A and angle P have to be the same. So angle A is like right here, angle P is right here. And the reason that I would give, if I've got parallel lines, is probably going to be one of my special angle pairs. So when I look at those two, they're on opposite sides of this transversal that I'm drawing in, but they're both in between the parallel lines. So these guys are my alternate interior angles. So the alternate interior angle theorem says they have to be congruent. Next I've got angle ABC. So ABC, this guy, is congruent to angle BPM. So PBM. Remember that the letter on the middle is the vertex, or the pointy part. Now when I look at these two, let's see, those would have to be the same because they are vertical angles, and vertical angles are always congruent. When I go to prove that triangles are congruent to each other, it's going to be one of my three reasons, SSS, SAS, or AA. The information that I've got is that this triangle has two angles marked, and they're the same size as the two angles marked in the other triangle, so I'm going to use AA. Not too bad, yes? We'll try some more when we come into class. But for now, we're going to look at three new theorems. The side splitter theorem, which says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. Alrighty, so when I look at this first triangle, I see the parallel lines here, and dividing the sides proportionally means we're going to be making some fractions. So like the relationship between x and 16 should be the same as the relationship between 5 and 10. And you could solve that by cross-multiplying, but I think, okay, 5 is half of 10, so x would have to be half of 16, which is 8. You try number 2, so pause, set up a proportion, and solve. Hopefully what you did was 6 over x, the relationship between those two, should be the same as 9 over 6, the relationship between those two. When I cross multiply, I get 36 equals 9x, so x equals 4. Cool. Numbers 3 and 4 down here are very, very similar. Instead of having triangles, we've just got parallel lines. So if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. A lot of crazy words in there. Intercepted just means they're intersecting or crossing each other. The transversals would be like WY and AC, these two lines that cut across the parallel lines. We can set up something very similar where the relationship between 2 and 5, so these two guys over here, have to be the same as the relationship between 4 and x. cross multiply, so 2x equals 4 times 5, which is 20, so x equals 10. Something cool that I wanted you to notice is that you could set this up another way too. You could also have 4 over 2, so 4 over 2 equals x over 5. And when you cross multiply and solve that, you get the same thing, x equals 10. So a lot of different ways that you could set these up. All right, number 4, pause and try it. Keep in mind you're going to have to set up 2 proportions because there are 2 unknowns. So maybe set up one up here to find x and one down here to find y. Alrighty, unpause. Hopefully you've got that x over 30, let's see, maybe x over 30 and 15 over 26. You might have set it up a different way, totally cool. But let's just see if you get the same answer. 30 times 15 divided by 26. Ooh, 17 point something? Let's see, that was 17.307. For y, we've got 16.5 divided by y should be the same as the relationship between 15 and 26. So 16.5 times 26 divided by 15, 28.6. Again, you might have set it up differently, but hopefully got those answers. And the last one, the triangle angle bisector theorem, which says that if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the 2 other sides of the triangle. Whoa, mouthful. What this is really saying is that the relationship between this side across from an angle and the side of the triangle next to it, so 9.6 over y, will have the same relationship as 16, side across from the angle, and 24, the side of the triangle next to it. Once you set that up, it's proportions again. So 9.6 times 24 divided by 16, 14.4. Pause and try number 6, same way. Alrighty, hopefully you have something maybe like 3.6 divided by 5 equals y divided by 8. Cross multiply, 3.6 times 8. Whoa! 3.6 times 8 divided by 5. 7 point, whoa, what was that? 5.76. 5.76. See you in class.